Well, both the quadratic equation method and our perfect squares method are suitable for solving some equilibrium expression. It doesn't work for all. And so therefore what we can do is we can look at some other techniques. Just like our other example, we still write out our balanced chemical equation, and we would do our ice table, writing in our initial concentrations, our change, and adding them together to get our equilibrium concentrations. We would also then write out our equilibrium expression. Now, before substituting my values in my equilibrium expression, what I'm going to do is I'm going to look at my value of Kc. And I can see that it's very small. In fact, it's 4 powers of 10 below my initial concentration. So this suggests that the change in my initial concentration is not going to be very significant. To be able to make this assumption, what I can do is I can perform a simple check where I take my initial concentration and divide it by my equilibrium constant. If this value is greater than 500, then it allows me to suggest that my change in my initial concentration is non-significant. So in this case, in this example, I take my initial concentration of my hydrogen, and the reason that I'm taking that is because it undergoes the largest change, but it also has the lower initial concentration. And I divide it by my equilibrium constant. I see that this is much greater than 500. So as a result, what I can say is that 0.345 minus x is going to be approximately equal to 0.345. And 0.325 minus 3x is going to be approximately equal to 0.325. I can now take these values and substitute them into my equilibrium expression. And using the approximate concentrations of my reactants, assuming that the change in x is not significant, I can get a value of x. And I can see that my change in concentration will be approximately 4.35 times 10 to the negative 4. Now what I need to do is I need to check my assumption. And so what I can do is I can take my change, and here I'll take the largest change, and also the lowest initial concentration, and I'll divide my change by my initial concentration and multiply it by 100%. And if this is less than 5%, what that tells me is that less than 5% of my reactant would change into product, and it would not be significant amount changed. And so when we do this, we find that it's less than 5%, so my assumption was valid. As a result of the change not being significant, I can now take this x value and use it to determine my equilibrium concentrations of each of my entities. And so I'll take this x value and substitute it into my E line to determine the equilibrium concentrations of the nitrogen, hydrogen, and ammonia gas.